Hello. Today I want to talk about charging electric vehicles, and specifically I want to compare and contrast AC charging with DC charging. And moreover, I want to get to the answer to the question, why is DC charging so much faster than AC charging? Let's start by considering what we need to charge. In this case, it's the batteries on board the vehicle. So batteries are DC components by their nature. DC stands for direct current, and a DC electric system is where there is a clearly defined positive and a negative. So just like a battery in a flashlight, a AA battery, you have a positive connection at one end and a negative terminal at the other end, and there's no switching around between them. That's positive and that's negative. Well, the battery packs that we use in our vehicles here, they may be 600 pounds and they may generate 350 volts, but they still just have a positive terminal and a negative terminal. They are by their nature DC components. That means that when you want to charge a battery pack in an electric vehicle, you have to provide DC electricity, where there is a positive and a negative, and the current flows in just one direction. In contrast, the grid that distributes electricity across the nation, or any country in the world for that matter, is AC, alternating current, where the electric voltage oscillates between positive and negative, positive, negative, positive, negative, 60 times a second, or 50 in some other countries. And so that oscillation is very useful for certain technologies for generating and distributing electricity, and it's great for things like industrial electric motors. However, it's useless for charging batteries directly. Therefore, you need a piece of equipment called an inverter, which takes the AC electricity and converts it to DC if you're going to use that electricity to charge batteries. You can't charge a battery directly by connecting it to an AC power supply. So, the primary difference between AC and DC charging is, where does that inverter live? AC charging is very convenient because you only need a fairly modest piece of equipment that controls the connection between the vehicle and your outlet in your garage, for example, for a passenger EV, a consumer EV. And so the AC electricity comes to the vehicle, it's connected to the vehicle, and it is still alternating current. And the inverter that converts from AC to DC is on board the vehicle. In contrast, with DC charging, the converter, which is that inverter, the conversion equipment that converts from AC to DC, is off-board. It is not on the vehicle itself, it is in the charging station. And I don't know if you've noticed, but DC charging stations are a lot bigger than AC charging stations. AC charging stations literally can be, I don't know, the size of my head, for example, whereas a DC charging station is usually a pedestal that's as tall as I am, probably weighs, 700-800 pounds, and it costs a lot too. Well, it makes no sense to have something that big embedded in a vehicle if you want to charge with AC. The inverter that you use on a vehicle, on board, has to be relatively modest in size, weight and cost, because no EV manufacturer wants to add hundreds and hundreds of pounds of weight to a vehicle just so you can do high current AC charging. Instead, the inverter for AC charging is modest, and therefore it can only allow current at a certain rate. In other words, your charging rate with AC is also relatively modest. In contrast, for DC charging, you have this pedestal shape charging station which is bolted to the concrete. It can be as big as you like and have a budget for, I should say. And that generates DC electricity, which is sent down the cable to the vehicle directly as DC, which is then connected directly to the batteries, and charging proceeds. The value of this, of course, is that you can have much more high current, high capacity inverter equipment in that pedestal that's not on the vehicle, which means you can charge much, much faster because you can send a lot more electricity to the vehicle as DC than you possibly can as AC. And that's the main difference why DC is so much faster than AC. Let me illustrate that by showing you this, which is the charging port that we put in our vehicles. This one is the J1772 CCS1 combo, which is very common across North America, and it's what we use in our vehicles. The top part of it here is designed to receive AC charging, and then the bottom part, which is these two pins here, is designed to receive the DC current from a DC charger. Let me turn this round and show you something that illustrates the difference in charging speeds. These two orange cables here that you can see where my finger is, those are for AC charging, and you can see they're fairly modest little cables because we know we're not going to receive much current when doing AC charging because our onboard electronics for converting to DC are fairly modest. DC charging, on the other hand, uses these two much heavier cables because we are expecting a lot more current when we're charging DC because the electronics is off-board and the current, the energy is going to come in much, much faster. The batteries are going to be charged faster. And so DC is the way to go for fast charging, and AC, although it's low budget, tends to charge slower.